Reliability is the consistency of measurement or the degree to which an instrument measures the same way each time it is used under the same condition with the same subjects. In short, it is the repeatability of measurement. Reliability is a necessary ingredient for determining the overall validity of a scientific experiment and enhancing the strength of the results. A measure is considered reliable if a person's score on the same test given twice is similar. According to Guilford, reliability is the proportion of the two variance in obtained test scores. According to Anastasi, the reliability of test refers to the consistency of scores obtained by the individual on different occasions or with different sets of equivalent items. According to Stodola and Stordal, the reliability of a test can be defined as the correlation between two or more sets of scores of equivalent tests from the same group of individuals. Methods of estimating reliability. There are a number of ways of estimating reliability of an instrument. Various procedures can be classified into two groups: external consistency procedures and internal consistency procedures. External consistency procedures compare findings from two independent processes of data collection with each other as a means of verifying the reliability of the measure. There are two methods: test-retest reliability, parallel forms reliability. Test-retest reliability. The most frequently used method to find the reliability of a test is by repeating the same test on same sample on two different time periods. The reliability coefficient in this case would be the correlation between the score obtained by the same person on two administrations of the test. Test-retest reliability is estimated when same test is administered on same sample. The assumption behind this approach is that there will be no substantial changes in the measurement of the construct in question upon administration on separate occasions. If the test is reliable, the scores that are obtained on first administration should be more or less equal to those obtained on second time also. The relationship between the two administrations should be highly positive. The time gap that is given between measures is of critical value. The shorter the time gap, higher the correlation value and vice versa. Limitations of test-retest reliability. Memory effect or carryover effect, practice effect and absence. One of the most common problem with the test-retest reliability is that of memory effect. When a memory-related experiment including nonsense syllables is conducted, there are a few limitations which include the following. The subjects are asked to remember a list in a serial-wise order. The next experiment is conducted within 15 minutes. Most of the items subject is bound to remember his or her responses, as a result of which there can be prevalence of artificial reliability coefficient, since subjects gives response from memory instead of the test. Same is the condition when pre-test and post-test for a particular experiment is being conducted. Practice effect. This happens when repeated tests are being taken for the improvement of test scores, as is typically seen in the case of classical IQ, where there is an improvement in the scores as we repeat these tests. Absence, people remaining absent for retests. Parallel forms reliability. It is known by the various names: alternate forms reliability, equivalent form reliability, comparable form reliability. Parallel forms reliability compares two equivalent forms of a test that measure the same attribute. When two forms of the tests are available, one can compare performance on one form versus the other. The two forms are administered to the same group of people on the same day. When both the forms of the tests are given on the same day, the only sources of variation are random error. and the difference between the forms of the test. Sometimes the two forms of the tests are given at different times. In these cases, error associated with the time sampling is also included in the estimate of reliability. The Pearson product moment correlation coefficient is used as an estimate of the reliability. The method of parallel forms provides one of the most rigorous assessments of reliability commonly in use. Often, test developers find it burdened to use parallel forms of reliability. Practical constraints make it difficult to retest the same group of individuals. Instead, many test developers prefer to base their estimate or reliability on a single form of a test. Internal consistency procedures. The idea behind internal consistency procedures is that items measuring same phenomena should produce similar results. Following internal consistency procedures are commonly used for estimating reliability. Split half reliability, Kunder-Richardson estimate of reliability, Cronbach's alpha. Split half reliability. In this method, we randomly divide all items that intends to measure same construct into two sets. The complete instrument is administered on sample of people and total scores are calculated for each randomly divided half. The split half reliability is then simply the correlation between these two scores. Problems in this approach. When the tests are shorter, they run the risk of losing reliability. It is more useful in case of long tests as compared to shorter ones. To rectify the defects of shortness, Spearman-Brown's formula can be employed, enabling correlation as if each part were full length. R is equal to 2RHH by 1 plus RHH, where RHH is correlation between two halves. KR estimate of reliability. The coefficient of internal consistency could also be obtained with the help of Kunder-Richardson formula number 20. One of the techniques for item analysis is item difficulty index. Item difficulty is a proportion or percentage of those answering correctly to an item. For example, symbol P is used to represent the difficulty index. Suppose an item X has P is equal to 0.67. This means item X has answered correctly by 74% of those who answered the item. To compute reliability with the help of Kunder-Richardson formula number 20, the following formula is used. KR20 is equal to n by n minus 1 into 1 minus sigma PQ bar variance square, where n is the number of items on the test, variance square the variance of scores on the total test, P the proportion of examinees getting each item correct, Q the proportion of examinees getting each item wrong. Kunder-Richardson formula 20 is an index of reliability that is relevant to the special case where each test item is scored 0 or 1. Example, right or wrong. Cronbach's alpha, as proposed by Cronbach and subsequently elaborated by others. Coefficient alpha may be thought of as the mean of all possible split half coefficients corrected by the Spearman-Brown formula. The formula for coefficient alpha is R alpha is equal to n by n minus 1 into 1 minus sigma variance square j by variance square, where R alpha is coefficient alpha, n is the number of items, variance square j is the variance of one item, sigma variance square j is the sum of variances of all items, variance square is the variance of total test scores. As with all reliability estimates, coefficient alpha can vary between 0 and 1. Coefficient alpha extended the Kunder-Richardson method to types of tests with items that are not scored as 0 or 1. For example, coefficient alpha could be used with an attitude scale in which examinees indicate on each item whether they strongly agree, disagree, or strongly disagree. Comparison of reliability estimators. All of the reliability estimators listed above have certain pros and cons. Example. Number 1. Inter-rater is best suited when the measure involves observation. It, however, requires multiple observers as an alternative. One can look at the rating of a single observer repeated on single occasion. It can also be used if the examiner is interested in using team of raters. Number 2. In a situation that involves use of two forms as alternate measure of the same thing, parallel forms estimator is best suited. 3. The internal consistency measure of reliability have constraints, that is, one has to have multiple items engineered to measure same construct. 4. Cronbach's alpha is useful in case where lots of items are present. 5. The test-retest reliability is mostly employed in case of experimental and quasi-experimental designs. This also depends upon strings of availability of a control group that is measured on two different occasions and until post-test is done. One does not have information about reliability. Accordingly, each one of the above mentioned estimators will give a different value of reliability. Generally, test, retest and inter-rater reliability estimates will be lower in value as compared to parallel forms and internal consistency due to involvement in measurement at different times or with different raters.